Hi, this tutorial is going to take a look at correlations, our Excel calculator. And you can see the tabs below we have information for correlation for two variables. And this is going to be just a simple walkthrough how we calculate that. For three variables, we go a little further, adding a couple of additional pieces of information, such as showing how to find a partial correlation and how to conduct a t-test of statistical significance for a correlation or a partial correlation. Uh, And then we have some relevant resources here. This is a correlation table that shows how big the correlation needs to be at different levels, at different alpha levels, which correspond to our confidence intervals, based on degrees of freedom or sample size. And then we've got our z distribution and our t distribution here. Particular relevance there will be our t distribution, so we'll come back to that. So the first problem, looking at the two variables being correlated, it says the following 6 students were questioned regarding their attitudes towards the legalization of prostitution and their attitudes toward the legalization of marijuana. Compute a Pearson correlation coefficient for these data and determine whether the correlation is significant. Okay, so the scores were from the problem were given in advance, and we could see so student A had a score of 1 in terms of their attitudes about prostitution, and a score of 2 in terms of their attitudes about the legalization of marijuana. And person B scored a 6 and a 5, and so on. So these are just the scores based on those two items uh, indicated above here. And to get to the correlation, we need to square these values, and we need to take the product of the values. So we have 3 additional columns that were calculated based on the scores given. All right, so you can see the formulas in these cells will implement those calculations. So the square of x is just b5 squared, and that's repeated all the way down. And then the same for the y column here. And then we're just multiplying x and y for this column. So in that row, it's b5 times c5, and then it continues down. Then we take the sum of all these columns, and then we take the averages for x and y. And the reason we do that is you can see this formula here calls for the sum of xy. So here's our xy column, and there's our sum, so that's going to be 83. Then we need our sample size, which in this case is 6. 1, 2, 3, 4, 5, 6 students. Then we need our x bar and our y bar. So there's our x and y averages, x bar and y bar, 3.8 and 3. So that's the numerator, and down here in the denominator we have the square root of 2 terms. The first is related to x, so the sum of x squared, so that's going to be this column. And there's our sum of x squared, that's 115, minus the sample again, 6, times x bar squared, so this value 3.8 squared. Same thing with this term, sum of y squared, there it is, 64, minus n, 6 students, times y bar squared. So there's our y average, 3 squared, that's going to be 9. All right, so this formula here then translates all of that into an Excel formula, right? So I know these can look a little bit hairy and daunting, but one thing you do have to remember is to use a lot of parentheses to make sure that the order of operations goes through correctly. Missing parentheses might throw off that order of operations and give you the wrong result. So once you plug all that in, you get a 0.85 correlation, which is a pretty high correlation. So, down here it says the substantive conclusion, attitudes about legalization of marijuana and prostitution are highly related. Now the question we have though is whether or not we can generalize from this sample of 6 students to a wider population, and that's where statistical significance test comes in. All right, so we need to know degrees of freedom. We have 6 students, and it's going to be minus 2 for the 2 variables in the analysis. So at a critical value of We need to find our critical value of t, rather, based on 4 degrees of freedom. Okay, so 4 degrees of freedom, and we're looking at two-tailed 95% test, so 2.78 is our cutoff. Cutoff value. Our calculated t-score comes from this formula. So we have t equal to the correlation of xy, so that's 0.85, times the square root of n minus 2, which is going to be right there. That's our degrees of freedom. That's 4. And all that is divided by the square root of 1 minus, again, the correlation of xy, but this time squared. Okay. So once you translate all of that into, well, here you can see I have a separate equation for the numerator, which is just the top part here, and below that an equation for the denominator. It's kind of nice to do that, break out when you have a kind of complex equation that you're trying to put into Excel terms, to keep the numerator and denominator separate, and then this cell just completes the calculation by dividing the numerator by the denominator, so b20 over b21 in that case. So you can see our calculated t is 3.2, which is larger than our critical value, so statistical correlation. Correlation is significant since t exceeds the critical value. You can also look at the correlation table at 4 degrees of freedom. At the 0.05 level, that's a 0.81 cutoff, and we hit 0.85, so we are above that value. So it's just another way of assessing significance, is using the correlation table, which allows you to bypass calculating t. But t gives you, this gives you a more precise significance test. All right, so this one's a little more complex because it has 3 variables, the next sheet here. So the data below, we're going to determine how job-seeking activity, x, may be related to the length of employment, y, and suppose that age, z, is added as a control. So we're looking at a cause and effect relationship here. The previous example is not cause and effect, right? Your attitudes about prostitution and marijuana might be related, but they don't cause each other. In this case, your job-seeking activity is going to cause your length of unemployment. So if you're not looking for jobs, you're going to stay unemployed longer, basically. Right? Age might be a related factor here, so that's thrown in as a control. So person 1, they scored a 2 in terms of their job-seeking activity, and the length of unemployment was 8, and they're 30 years old. Okay, so that's how it just stays like that all the way down through each of these individual cases. Again, in addition to the scores that are given by the data, we have to do some calculated columns. So again, we're going to square each of those columns, and then we're going to find the products between xy, xz, and yz. And that will allow us to calculate 3 different correlations, right? So we have a correlation for xy using the same formula for each of these 3, except substituting xz instead of xy, or yz instead of xy. Right? But basically the same formula. Same math as before, so I won't go into that. You can see the correlations appear here. And then the question also wanted to know about a partial correlation. So what is the effect of the independent variable job-seeking activity on the dependent variable of length of unemployment controlling for age? Okay, so this is the formula for how we calculate a partial correlation. So the partial correlation notation is the rxy dot z. Dot z means we're controlling for z. In the numerator, which is captured here in this Excel, in this particular cell, just calculating the numerator, is rxy, so our initial correlation, minus the product of the other 2 correlations, right? So minus 0.84 times negative 0.6. Okay, in the denominator, we've got these terms, the square root of 1 minus the xz squared correlation, and the y over here the YZ correlation. Okay, so that's what that looks like in terms of our Excel formula. And then this completes the calculation. So while initially the correlation was 0.69, meaning that as we increase our job-seeking activity, our length of employment goes down. Right? That's in a pretty strong way. 0.69 is a pretty strong correlation. But when we control for age, it actually is a more moderate, much weaker correlation. So that means that age is having an important effect on length of unemployment beyond job-seeking activity. So here's how we test for statistical significance for the correlation. Same as before, right? We did this on the previous example. And then we have a special test for the partial correlation. The formula for that is here. So calculating t for a partial correlation involves the partial correlation. Similar formula here, but now n minus 3 degrees of freedom. And then instead of the regular correlation, it's the partial correlation in the denominator. So it's really just an adaptation of this same formula. And we can see those are the resulting values. So the first one is a negative 3, which is much larger than the second, which is a negative 1.4. Okay. So the critical value, you can see negative 1.8 is larger, so the correlation is no longer significant when we control for age, although originally when we didn't control for age, the correlation was significant. So the statistical correlation, correlation statistically significant since t exceeds the critical value. But we need to add here also, however, the partial correlation is not significant. Oops, this needs to be updated. So the substantive conclusion is that job-seeking behavior does influence length of unemployment, but not when we control for age. So that's how we do that. All right, so those are some useful pieces of information in terms of calculating correlations, partial correlations, and also examining statistical significance. Thank you.